Okay, let's look at this. So the next one I want us to look at is x squared minus 3x, that quantity raised to the fourth power, plus 5 times the quantity of x squared minus 3x to the second power, plus 6 is equal to 0. Now, what is it that I hope you realize or recognize? I hope you recognize that I have some base raised to the fourth power, and then I have that same base raised to the second power. What does this tell us? We could potentially factor. We could potentially factor, right? We have some base raised to the fourth power, the same exact base raised to a power that's half of the first one. So I'm going to use substitution. I'm going to let m equal the quantity of x squared minus 3x raised to the second power. So now we have m to the fourth, m to the second, plus 5m squared plus 6 is equal to 0. Not as intimidating anymore. Can we factor this? Absolutely, we can factor this. So I'm going to get m, I did square twice, sorry. So I'm going to have m plus 3, m plus 2 equals 0. Then I solve. M will equal negative 3, m will equal negative 2. This was the easy part. Now we have to substitute back in. We can't stop here. So I substituted to let m equal the quantity of x squared minus 3x squared. Now I have to substitute back. So I'm going to have x squared minus 3x quantity squared equals negative 3. Everybody good with what I've done so far? Now I need to solve for x. To undo a square, I'm going to take the square root on both sides. The minute I take the square root, what do I now have to do on that left side? Plus or minus. So now I have x squared minus 3x is equal to plus or minus I root 3. I pulled out the I because we had a negative underneath the radical. I'm still solving for x. I still need to solve for x. This is the part that's probably going to throw you. Are you ready? Yeah? Okay. So what I'm going to do now, I see an x squared, I see an x, and I see a constant term. This is a constant because I is not a variable. I is a number, right? We know what I represents. So this is absolutely our constant. So what I'm going to do is I'm going to move it over. Now, I can move it over into two different equations. I can say x squared minus 3x plus I root 3. And then I could do another one where it's x squared minus 3x minus I root 3. Or I can make my life a lot easier, and look what I'm going to do. I'm going to write it as x squared minus 3x plus or minus I root 3 equals 0. I am not going to be able to factor this. Since I'm not going to be able to factor it, but it is a quadratic because the degree of the polynomial is 2, what can I use?
The quadratic equation.
The quadratic equation. So for the quadratic equation, I know x is equal to negative b plus or minus the root of b squared minus 4ac all over 2a. Just verbally tell me, what's my a? What number? 1. What's my b? Negative 3. What's c?
I
Plus or minus I root 3. All right, so let's go with this. So we're going to have x is equal to negative b, so I'm going to have a positive 3, plus or minus the square root of negative 3 squared, which is 9, minus 4 times 1 times plus or minus I root 3. All over 2. Are you all still with me right now? Okay, let's keep going. X will equal 3 plus or minus the square root of 9. Obviously, this one makes no difference. So I have negative 4 times plus or minus I root 3. Well, if I do negative 4 times positive I root 3, then it's a negative 4 I root 3, right? But if I do negative 4 times a negative I root 3, isn't it a positive 4 I root 3? So what I'm going to do is I'm going to do 9 plus or minus I root 3. Oh, sorry, 4 I root 3. You can have an I under the radical. We're allowed to leave the I under the radical. We're allowed to leave the radical under the radical. That's all okay. We can leave it just like that. All over 2. This is our answer. That's one answer. We're not done. We go to the other side now. Remember, there was a whole other side to this? So we have on the other side m equals negative 2. So now, remember, we used substitution. We said m would substitute in for x squared minus 3x. Was it quantity squared? Yeah, quantity squared equals negative 2. Now we solve for x. To undo a square, we will take the square root of both sides. So now we have x squared minus 3x equals plus or minus I root 2. Same thing we just did. I'm going to move that plus or minus I root 2 to the other side. And now I will use the quadratic formula. So I will have x is equal to 3 plus or minus the square root of 9 minus 4 times 1 times plus or minus I root 2 all over 2. So x will equal 3 plus or minus the root of 9 plus or minus 4I root 2 all over 2. And that is our third and fourth answer. Oh, no, much more than third and fourth. Let's go. Yes?
Why can't we just move the 3x to the other side and square root?
So let's go back to this first one. So you're saying, can we do x squared plus 3x equals plus or minus, let's say, I root 3. So you're saying take that 3x to the other side? So x squared is equal to negative 3x plus or minus I root 3. And then you square root it, but then you still have that x underneath of here. You want to solve for x. Can't solve for x if x is in it. Okay, so how many solutions is this actually? 8. Let's go back. Should we have had 8 solutions? Yes, because if we were to multiply this all out, this x squared, this whole quantity raised to the 4th power would eventually get us x to the 8th as our leading coefficient. I'm sorry, our degree of the polynomial, not leading coefficient. All right, let's keep going. Next one. Okay, so we're not going to get intimidated by the double radical. We are not. I'm going to change this to exponential, So this is the quantity of x minus 2 raised to the half power, plus, now we're going to have the quantity of x minus 2 raised to the half, but then isn't it then also raised to the half again because of the double radical, equals 2. Well, what do you do with a power to a power? You multiply it. So this is the quantity of x minus 2 raised to the half plus the quantity of x minus 2 raised to the 1 over 4 equals 2. What is it that I really hope you recognize here? Good. First thing I hope you recognize is they both have the same base, and that the first exponent is double the second exponent, which means what? We can potentially factor. So I'm going to use substitution. You don't have to if you don't want. I'm going to let m equal the quantity of x minus 2 raised to the 1/4 power. So that leaves me with m squared plus m equals 2. I'm going to move that 2 over, and I will factor. So m squared plus m minus 2 is equal to 0. Easy peasy factoring. And then we solve for m, and we get m equals -2 and m equals +1. We do not stop here. Why not? We have to substitute back. So now I will substitute back, and I will take my quantity of x minus 2 raised to the 1/4 is equal to -2. Okay, I know this isn't going to work out, but let's keep going through the motions. Let's say you went through and said, okay, well now I need to solve for x, so I'm going to raise both sides to the 4th power. We're going to get x minus 2 is equal to +16. X will equal +18. But because this was originally a radical equation, basically any equation that has radicals in it, you have to check your solutions. So I'm going to check that 18. So here we would have 18 minus 2 is 16. Square root of 16 is 4. And then here we have the square root of the square root of 16. Well, the square root of 16 is 4, and what's the square root of 4? 2. So then we're left with 4 plus 2, which is 6, not 2. So does that 18 work? No. So we reject the 18. Does not work. Now we go to the other side, and we're going to sub back in now x minus 2 raised to the 1/4 power equals 1. Raise both sides to the 4th power. So then we get x minus 2 is equal to 1. X will equal 3. Now we check this one. Let's go back. Here we have the square root of 3 minus 2, which is 1, plus the square root of the square root of 1. Well, square root of 1 is 1. Square root of 1 is 1, and then the square root of that 1 is another 1. What do we end up getting? 1 plus 1, which is equal to 2. That one does work. So our only solution here is x is equal to 3. Danny? When you have a radical, or you have any radical in your equation, you check your solution. So if you, tell me one more time. your dumb question.
Okay, so it feels like the original problem is that, like, the original leaves are genius. So, you see how, like, in the original, like, triangle that we made, technically, like, if instead of having x minus 2, we had x squared minus 2 to the raised to the 1 half power plus x squared minus 2 to the 1 fourth power minus 2. Would you want us to factor and treat it like it was raised to the 1 half power like we just did? Or would you want us to, like, do it together in a different way?
So you're saying if it was x minus 2 raised to the half plus x minus 2 raised to the 1/4 minus 2
Yeah, but the x is raised to it.
in here, like that,
Yeah.
you would factor it.
Okay.
There's nothing to foil. There's nothing to foil.
But, like, we still have the solution to go back and substitute it.
You would still have to because of these radicals. Anytime there's a radical, you have to check it. Okay, let's keep going. Did we solve these? Yes, we solved this one. Okay, so there's a bunch of different ways we could go about solving this. I'm probably going to do it a way you wouldn't really think of, but it's probably the quickest. So what I'm noticing here, this is 2 over x plus 1 over x to the half equals 1, right? This is an exponent of 1. So in this denominator, I'm realizing, okay, well, I have x to the first, and then I have the same base x raised to the half. Isn't that first exponent double the second one? So I could potentially factor here, but I can't factor when it's in the denominator. So what am I going to do? I'm actually going to move them up. So this is going to be 2x raised to the negative first plus x raised to the negative half equals 1. Okay, now what I'm going to do is, once again, this looks a little bit more like something I can factor. I can go ahead and use substitution. I'm going to let m equal x to the negative half power. So this brings me to 2m squared plus m equals 1. Going to bring that one over. 2m squared plus m minus 1 is equal to 0. And now I factor. We get 2m minus 1 and then m plus 1. We solve. We'll get m equals positive a half and m equals negative 1. I'm now going to substitute back in. So we have x raised to the negative half power is equal to 1 over 2. Well, this is the same as saying 1 over the square root of x equals 1 over 2. I'm now going to cross multiply. So I get the square root of x is equal to 2. Square both sides, and I get x is equal to 4.
Is it okay, but, like, I did x is negative 1 half squared and then
Yeah. So we get more than what